Okay, let's try these two problems now. We're taking negative 64 to the 3 halves. First of all, notice that the negative is inside the parentheses, so that is being affected by the exponent, right? Whereas if you had a negative on the outside out here, down at the bottom there, that wouldn't be affected by the exponent because it's on the outside, okay? So that's going to equal, well, we've got a little bit of a problem because we have an even power, or we have an even, I shouldn't say an even power, we have an even radical. That's called a radical. That's like a square root, right? So you could think of it as negative 64 to the 1/2 power all to the 3rd power, because I'm basically applying this property number 2, rule number 2.
Okay.
But can you take the square root of a negative number? Not in the real number system, you can't do that. You can do it in imaginary numbers, but this problem comes from a real number solution. So you would say right away no solution, or does not exist, or we could say no solution, probably is what you want to say. Okay. Now what if this wasn't a negative? What if that was a positive? If that was a positive, then you could take the square root of 64, which is 8, and then you would cube 8.
Cube 8. And then
and that's your answer. But you can't do that since it's negative. All right, let's do the bottom one. So this one, a negative power, remember what a negative power just means, that it's 1 over, look at the property number 6, rule number 6. I'm sorry, not rule number 6, rule number 4, which is really a definition, not a rule. It's the definition. Anytime you have a negative power, you can rewrite it as a positive power by putting it on the other side of the big fraction bar. And now this equals 1 over, now again, let's do that thing where we take the 1/3 power first, because it'll be easier to do without a calculator, and then put the 4th power. So what's 27 to the 1/3 power?
27 to 1/3.
That's 3.
9.
That's 3. And 3 to the 4th is, do this thing right here. What's 27 to the 1/3? 3 times 3 times 3 is 9. Is 27.
27, okay.
And what's to the 4th? Well, that's 9 times 9, which is 81. But it's, remember, 1 over 81. So that just equals 1 over 81. Let's try one more. Same kind of thing, right? This negative power, I first do what?
First.
Flip it to the bottom and make it a positive power.
Okay.
That's the first step. Now what? Rewrite this as 32 to the what power?
32 to the
1/5.
Oh yeah, here's your 6. Yeah.
And then to the 4th.
Yeah.
Right, think of 4/5 as 4 times 1/5. And you can choose whichever one you want to go first.
Okay.
But we obviously want to do the radical thing first, because if we raise 32 to the 4th power, it's going to be a huge number, and you're not going to be able to do that without your calculator.
Right.
At least not very easily.
Right.
What's 32 to the 1/5 power?
32 to the 1 is...
You should know your powers of 2. 2, 4, 8, 16, 32, 64, 128, 512, 1024, 248, 496. You should know all your powers of 2.
Okay.
You should be kind of in your head. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. Just keep doubling it. 8, 16, 32, 64, etc. So this is just, you know, 32 is one of those numbers.
Right.
Right, like think of your iPhones. Your iPhones they're always a power of 2, the amount of memory they have on them.
Okay.
32, 64, that's because computers work with memory and stuff is a binary thing. It's powers of 2. It's all based on powers of 2.
Okay.
So 32 to the 1/5 is what?
6.
Nope.
8.
There it is right there. It was 2 to the what power? 5th power. So that's just what? 2. What's 32 to the 1/5 power? 2. 2 to what? And what do I still have? 2 to the 4th. And what's 2 to the 4th? think of 2 to the 4th as 2 squared times 2 squared. 4 times 4.
16.
So your answer is 1 over 16.